Okay, so section 6.2 is going to be very useful to help us find out probability calculation. So in other words, we are going to learn those three different situations, right? Using that table, the Z table, to help us solve all kinds of probability questions. Uh, so 6.2 here is all examples. In other words, right? The knowledge, we have this already. Okay, the table we are going to use is that Z table. Now, example number one here, on average, we are given those information. Female spending $146.21 on beauty product every month. Standard deviation, $29.44. Everybody? So like when they are talking about those information, by default, they assume, right, if we connect the female spending dollar every month on the beauty product, right, they will follow a normal distribution. So whenever they see they give you those information, everybody, like they tell you what's the average, right? The average spending and the standard deviation. That by default, this distribution follow a normal distribution. Remember, normal distribution is the most popular distribution in this world. You can consider that way, right? So here, this data sequence for the female spending every month on a beauty product, right? They follow a normal distribution. So that's kind of implied information here. Average $146.21, right? It's not our judgment to, it's not our judgment, like judgment to say is that too high or too low, right? Different people have a different living style, okay? But the average is $146.21, okay? Now, we want to find out the probability of any female, right? Probability of you randomly select any female, find out that female spending less than $160. So what's that mean, everybody? That means, so we can start drawing our picture, right? Say, let's see, we have usually, we started with two curves, right? The first one here is the normal curve. Let's see. Wow, I did not draw this very well, okay? It should be a bell-shaped form, okay? They tell you the average is about what? It's about 146.21, right? Now, that's the center, remember? Center, average, mean, median, mode, they're all at the center, right? Now, they are asking any female spending less than $160. So where's 160? Like let's say somewhere here, right? 160. Everybody, based on the information we are asking, tell me, they're asking the probability to the left, to the right, or in the middle, which one they are talking about, right? So there's less than, right? Less than human language, less than, that means everything to the left. Is that right? Less than. So in other words, we are trying to find out what's the probability for everything to the left of 160. Follow me? Is that clear? Right? So now, if you understand this question, now you may feel like excited. Now, what if we just check the table, the Z table, right? Remember, we have this Z table here. We just need to look for, what's that number? 160, everybody. Let's check out, right? So where's 160, everybody? Follow me, let's check out on the Z table. If you can open your Z table on your computer, everybody, download that Z table from the canvas, okay? I want you to get some exercise here. It's going to be very, very important. I uploaded that earlier. So now, remember, the Z table give you everything to the left. Is that right? Everything to the left, which is exactly the one that we are asking here, everything to the left. Is that right? Yeah. So we check 160. We need to get that value. Is that right? Everybody, 160, let's see, we have the Z. Those are the Z numbers, right? So let's check out Z, where is 160? Okay, we have like 0 0.1, like 0 point something, 1 point something, 2 point something, 3 point something, right? And how about 4 point something? We don't have that, okay? How about the other page? The other page is a negative 1.1 something, 2 point something, negative 3 point something. We do not have 160. Everybody, what's happening? Anybody know why? So the tricky part, everybody, we cannot apply this table directly here, 160. Why? Let's review this table here is what? Is what do we call this Z table? Is it right? Z table means what? Standard normal distribution table. Let's ask ourselves, is this distribution here standard normal distribution? Yes or no? No. Why is that? Because where's the center? The center of a standard normal distribution has to be what? 0. But the center for our distribution here is what? 146.21, right? That's not the standard. It is a normal one, everybody. This one here, we say it is a normal, right? We cannot say it's a standard normal one. Follow me? It is a normal distribution because it's a bell-shaped form. I did not draw this very well, forgive me, but it is a normal distribution. Okay, so in other words, we cannot apply this table here because this table, we can only apply this table for standard normal distribution, right? That's the one condition. As long as you find that one condition not satisfied, then it is a not standard normal distribution, right? The second condition, if you want to double check, the standard deviation here, 29.44, right? It is not equal to 1 to be standard. You have to be equal to 1, right? Remember, so none of those two conditions satisfy, right? As long as you find out 1, then that tells you you cannot apply this table directly. So what we have to do is we want to apply transformation from this table to the standard normal distribution table. Let me try to draw the curve here, everybody. So now let's see the standard normal distribution table. I'm trying my best to draw this. So the standard normal distribution table, the center should be 0, right? That should be our center. Standard deviation should be equal to 1. Got that. Now, how do we transfer to the standard normal distribution table, everybody? The Z formula we mentioned earlier, that is the one we are going to use. Remember, we mentioned we are going to apply this Z formula many times, and this is our first time here, right? So we starting from this normal distribution, we are using any letter like X, right? Whenever we convert to the standard normal distribution, we indicate this curve here, Z. So in other words, all the number here is what? Z, right? The number here is what? X, right? So in other words, we want to convert all those numbers here to the corresponding number on the Z axis here, right? You can imagine the center, should we go to the center, right? So in other words, 146.21, from the graph intuitively, is that right? Center to center, is that right? 146.21 should go to 0, right? You may wonder why is that? Let's check out the formula actually, is that right? That's the formula, everybody. So Z is equal to X minus mu. Mu is the average, is that right? Average is given 146.21, is that right? And then standard deviation divided by standard deviation divided by 29.44. So that formula here is the formula we are applying, this one here. Is that right? Now, for example, if we want to find out what's the center corresponding mapping to here, is that here or is that somewhere else, right? Is the 146.21, this particular number here, X, right? We are mapped to what's number here, right? So what do we need to do, everybody? We apply X equal to 146.21. check out what's happening. If you plug in x equal to 146.21, this number, the numerator becomes what? 0. Is that right? 0. 0 divided by anything is what? 0. So that confirms our guess in the beginning, right? We are kind of thinking, oh, this should be go to center to center. It turns out it is the case. Follow me? Right? Now, to give you a more specific example, let's find out what's this 146 corresponding to, right? 146, right? We want to find out 146. This number here, they may map to some number, right? Like 146, is that somewhere here? Trying to draw that, right? Or somewhere here, right? Intuitively, because 146 is like a bigger than the center. Then when after we do the mapping, this number here should be also bigger than the center. So we know it should be on this side, right? Not this side, right? So this like some Z here, we are trying to find it. Everybody? How do we find out Z?
Divide 0 by 29.44.
Yeah. So we are going to apply the formula here, everybody, right? So you plug in x equal to 146, right? So into this formula here, so 160, sorry. 160 minus, that's the what I have here, right? 160 minus 146.21, right? Divided by 29.44, right? So doing that, plug in 146, right? Plug whatever you have for this x value, you got this number here, everybody, 0.47. That's the Z number you are looking for, everybody. One thing I want to point out here, everybody, on the when you are working on the homework, right? Working on the exam, you don't have to write down this way. You don't have to write down this way, right? Because this is for like, if you are interested in mathematics, if you are interested in graduate school, right? You can write down this way, okay? Otherwise, you can just write a formula like that. That's good enough, okay? As long as you know, I mean, try to draw those two pictures. You got it very clear. 146, we are mapped to this number here. By the calculation, Z is equal to what? Everybody? 0.47. Follow me? Right?
Professor, I have a question.
Go ahead.
I thought X was 146.21. Why is it now changing to 160?
Okay.
For that?
Yes. Yeah. The X is this, any number on this X-axis, is right? So earlier, when we tried to plug in X equal to 146.21 is the center, agree? Is
yeah.
Right? So we are trying to find out like, oh, this center should be mapped to where? In the Z curve, standard normal curve, right? So when we plug in X equal to 146.21, we got 0, is that right?
Yeah.
Yeah. Now, that's not our focus, is that right? Our focus is what? Is 160, remember?
Yeah, we want to figure out the equation from the X score to the Z score.
That's right, that's right. So the one that we really have to plug in is this number here, 160.
So the true X is 160, but we were just using that to transform it into the standard normal distribution so that we can use the table to figure out the score.
Yes, the one that we are using here is the one that we want to find out what's the corresponding number for the 160. We are you see this number here. I don't want you get it confused for this 160 here. Let me see. Let me try to draw this 146.21. You know where this coming from?
Yep, that's the average.
That's the average, exactly. That's in the formula. You always have this average. Remember the formula previously is X minus the average. Is it right? That's the
yes.
Yeah. So X can be anything. That's right. Yes. X is like this case here. We are worried about 160. That's the question they have asking here. Is it right? 160. That's the reason we plug in 160 as X.
So am I correct in assuming that both the transformation formula and the solving formula are the same formula?
To me, there's only one formula.
Right, so they're the same.
Yeah, that's the only formula we are studying.
Okay, thank you.
Mm-hmm. Any other questions?
Yes, Professor.
Oh, go ahead.
Go ahead.
Pardon me. Is the standard deviation always given?
Most of the time, standard deviation is given.
Thank you.
Yeah. Somebody else has a question?
Yeah, so for the z-score that we use in this problem, is that the formula for a sample or a population, or does it matter?
Yes. This is we are using the mu, we are using the standard deviation. So if you read this one here, it's like it's either from a sample or from a population. So in that case, the mu, we are using the notation mu and sigma, that is for population, is that right?
Okay, yes.
It is for population, to answer your question, yes. Yeah.
Okay.
Any other questions? Okay, so we find out the 0.47, everybody. Now it's time to use that Z table. Remember? So that's the one you can apply the Z table right now. Let's see. You apply this 0.47. Is that right? Let me erase. Where's the 0.47? 0.47. Let me erase some other part here. You don't get confused. All right. So where is my 0.4? Follow me, right? 0.47. This one here. Follow me. So we got the probability here is what? 6808. Everybody, this is very, very important. If you have the Z table open, try to find that from your Z table. Everybody, because this is online class, it's difficult for me to check each person actually follow up, right? Understand what's going on here. 0.6808. If you got confused how to use this table, okay, you need to talk to me during the break or talk to your study partner as soon as possible. Okay. In other words, if you got stuck here, you cannot continue for this class. Let me put that one. Okay. So we got 6808, right? 6808. Everybody, that's the probability we have. 6808. What does that mean? That means we're starting from this point here, right? 0.47. Everything to the left, everybody, everything to the left. Remember that the Z table is to tell you everything to the left is what? 68.08%. Okay, so that's the area here. To the left is 68.08%. Everybody, that also means the probability when we going backward to the original normal distribution here, the highlight area, the probability we are looking for is also 68.08. So we can kind of understand this as when we do the transformation, everybody, they have to preserve the probability. Whenever we do the transformation, the probability should be always the same. It's like if you study some physics in high school, right? It's like energy is always the reserve constant, is right? So they change from one format to different format, but overall energy should be the same. It's the same as here. The probability, right, to the left, after we do the transformation, it should be the same probability. Follow me, everybody? So in other words, we say the probability of the female spending less than $160 is what? Is this one here, 68.08%. Is that clear, everybody? That's the way to answer this question. So whenever you try to solve this probability question, everybody, I try to encourage you to draw two curves. You don't have to write down this way here. You don't have to write down that, okay? Like put here a P bracket. You don't write down that, okay? But you do want to write down something like using these two curves here. Draw out, right? Where's the center? Where's the X? And where's the mapping go to? and find out from the mapping where's the corresponding z. Now, once you got the z, you can go back to the z table to find out what's the corresponding probability. Now you are going backwards, then tell you here is the corresponding probability. Any questions? So that's the way to answer this kind of a question. Is very, very important, everybody. That's our first example. I'm going a little bit slow. Later on, we will be a little bit faster, okay? Any other questions before we move on? I'm going to erase that. All right. So the second example, once you understand one example, the other example will be very, very similar. That's the beauty, right? So once you understand one case, easy apply to the other case. Okay. Second example here. On average, each family generates 28 pounds of trash, right? Given the standard deviation, 2 pounds. Everybody? So in this case here, based on this information, we assume, right, if we collect the data in terms of each family, like every week, how was the trash, coming out, is that right? That a data sequence. If we plot them by using that histogram, right, you will see that it will be a normal distribution, the bell-shaped form. Okay, so that's the reason the normal distribution is so popular, right? Whenever they see something like average, standard deviation, kind of imply here, data sequence follow normal distribution. Okay, now the question is asking us, find out the probability that generating between 27 and 31. So in other words, this is our x, right, everybody? So as we mentioned earlier, try to draw two bell-shaped form. Everybody, do not be lazy, okay? You don't have to write it down like that, okay? You don't have to write down, but try to draw the picture, try to be very clear. It will help you reduce the mistakes, okay? So we know the center is 28. That's the one we have here, 28, right? Okay, everybody, tell me, is this curve is a normal distribution? Yes, it is a normal distribution because that's a bell-shaped form, right? Okay, now tell me, is this distribution a standard normal distribution? No, because the center is 28, it's not at 0, right? So in other words, we have to transform to be standard. So in other words, we have to transform to z, right? The formula is the same formula we have used, right? Z is equal to x minus mu, right? X minus mu divided by sigma. The same formula, right? So what do we need to find out? The question we're asking, what's the probability in the middle, everybody? So we just need to find out the corresponding data points. For example, 27, we have been mapping to some point here, right? Try to find out that data points. Similarly, 31, some data points here. Because 27 is below the average, so that's the corresponding number 1 should be below 0. You can think of that intuitively, right? In terms of exactly what this number 1 should be, plug into the formula. Everybody, x minus mu, what's mu here? 28. So x minus 28 divided by 2, right? So that's the formula, this part here, right? So what is that in this case? X is 27. That's the one we want to find out, corresponding map, right? So 27 minus 28 divided by 2 give you negative 0.5. Follow me? So this number 1 here is what? Negative 0.5. Okay. Similarly, we want to find out like 31 corresponding mapping to some other data points here, right? So 31 minus 28 divided by 2, 1.5. What does that mean? This number here is what? 1.5. Everybody, follow me? So now we know those two numbers here, and we are trying to find out probability in the middle. Everybody, I assume everybody knows how to use that Z table, right? So let me do this one more time. Apply this Z table here to try to find out the probability in the middle, okay? I'm not going to show that later, okay? So first, let's find out 1.5. Is that right? 1.5, let's see. 1.5, where is the corresponding probability? 1.5, 1.50 is right. Here, 1.50, this one here, right? Line 332. Follow me? Line 332. So that's everything to the left, right? Everything to the left. Now, we have to minus that area. Is it right? Because we are only asking the probability in the middle, remember? Is it right? So we minus this area corresponding to negative 0.5. So let's see, where is negative 0.5? Right, negative 0.50, check that. Negative 0.50, this one here. Is that right? So that's the one, negative 0.50. Follow me? Negative 0.50. So that'll give us the probability of 0.3085. Now we subtract those two probability. You see, 9332 minus 0.3085. That's the probability you're looking for. That's the probability in the middle. Everybody, I don't have the calculator here. You can do that directly to find out what's the corresponding probability, right? So that will give us the probability in the middle, this one here, right? And we mentioned that before, this kind of a transformation should preserve the probabilities, right? So in other words, what probability you have here should be the same as what you have over there, right? So you have like this number minus is like 62 point something, 62.27, something like that, right? That means that here should be also that. Let me write down this, should be 0.6227, I think. You can double check my calculation. 47, 47? Next 47. So 6247. Okay. 0.62. Okay. Now let's. Any questions for this example here?
Professor?
Yeah.
For the second graph, is that an 8 or a 0 in the center?
That's a zero. Remember the standard norm curve, the center is always 0. Is that clear? I don't know, I think it's because my computer or something. There's a here, right? You may get it confused. It's 0. Okay, to answer your question. Yeah. Any other questions? Otherwise, we can continue. Other example here. Let's see. All right. Now, so the same question. Go ahead.
So, Professor, sorry about that. So just a summary, what I'm understanding is that when we have a graph that's basically an X graph, we're obligated to convert it to a Z graph. And by using the formula, basically probability minus probability, I think so. And then we get the Z graph. And then when we get the Z graph, we point out the Z point using the Z chart. Is that
That's
it?
right. That's right. So once you got those Z numbers, like you have like Z1, it's like this is the Z1 here, and then this is the Z2 here, then using the Z chart, this chart here.
Okay.
Yeah.
So why is there a subtraction with the probability minus probability?
Yes.
Oh, is it because it's a middle shade?
That's right.
Okay.
Yeah. Remember earlier we mentioned for the probability in the middle case is like a 2 probability subtract.
Okay.
Yeah.
Thank you, Professor.
No problem. All right, let's continue. Feel free to stop me any questions. Question number 2 is actually the same information we are given, but they changed the question a little bit. So they're asking the probability of any family, right, generating more than 30.2 pounds of charge, right? So in other words, is like now you have this new Bell-shaped form, right? Where's the center? 28, right? And then you want to find out the probability more than 30.2. Everybody, tell me, using human being language, 30.2, more than 30.2. Is that to the left or to the right? It should be to the right, right? So to the right, that's the probability we are looking for. So what do we do, everybody? We are trying to do the conversion, is that right? Trying to find out what's the corresponding, like the Z mapping corresponding Z we have. When we have 0, right? So we are thinking this 30.2 should probably map into somewhere here, right? Bigger than 0, right? Somewhere here. How do we find out this Z here, right? Plug the Z table, Z formula, right? Z formula we just learned that is what? Is X minus mu divided by sigma, right? So 30.2, that's X minus 28 divided by 2. So if you do the calculation, should be equal to 1.1, let's say. 2.2 divided by 2, so it's 1.1, right? That 1.1 here, if Z is equal to 1.1, everybody, how can we find out the probability to the right of 1.1? Everybody? So we are using this, we can use this table here. Let me see. We can use this table here directly, so right? Let's see. 1.1, let's see, where is that? So it's like 1.10. Follow me? 1.10. This one here. Right? 8643. That's the probability we are looking for. 8643. So that's everything to the left, everybody. Everything to the left is what? 0.8643. Everybody? So sometime tomorrow, if you have some time, right, go over those examples, everybody. Go over those examples. Make sure you understand how do we do this step by step. So once you understand those examples, then when you work on those homework questions, right, it will be much more clear. Okay. So that's here to tell us probability to the left of 1.1 is what? 86.43%. Now we ask the probability to the right, this area here. It will be what? 1 minus that, right? 1 minus that probability will be like less than 14%, 13 point something percent. You can do the calculation. Everybody, follow me? Is that clear? So
Got it.
go ahead.
Yes, sir.
So I understand that we got 1.1 as a probability. Do we not subtract it from 1, or the answer is just 1.1?
1.1 is the Z numbers, right?
Yes.
Yeah, so from here, you find out the 1.1 is from, now you go back here, that's the corresponding probability, 86.43. That's everything to the left, is that right?
Yes.
But they are asking more than, is that right?
Mm-hmm.
Tell me more than that is to the left or to the right?
To the...
If they're asking something more than 30.2, is to the left or to the right? That's another mathematical question, is that right?
On the chart, on the standard distribution or the standard normal distribution chart, to the right of that 30.2 is what they're asking for, that area to the right, not anything to the left of it. And since everything on the chart has to equal 100%, you have that 8642, whatever it was, 0.8643, that's like 86%. So the remainder of 1 minus 86% is like 13 or 12, yeah, 13%.
13 some percent, yeah.
Okay.
So that's why you subtract 1, because it wants everything to the right of that number, not anything to the left of it or in the middle.
Okay, so my question is, did we actually subtract from 1 or no? Or is that what we're doing with the table then?
So I did not finish everything here. So if you want to continue, you have to do 1 minus point whatever you have here, right? 0.8643.
Oh, I see. Okay. Thank you.
Yeah. And then you try to calculate like a 0.13 something. Is that clear?
Yes. Thank you.
No problem. Let's move on. So that's our second example. So when we have more and more example, you will see, I mean, hopefully you will understand better and better, right? More clear, okay? So we have the cover. The first case is to the left, right? Less than, that's to the left. And then the case in the middle is right. The number 3, that's more than, that's to the right. So in other words, we have covered 3 situations. Make sure you feel comfortable to work on those 3 different situations. Okay, now the other example will be very straightforward. Example number 3, on average, a person consumes 1.64 cup of coffee per day. The standard deviation 0.24 cups, right? So whenever they are giving us this information, they assume if we connect the data for each person, like how many cup of coffee per day, that data will follow a normal distribution with the average 1.64 cups, right? A little bit more than 1, right? But less than 2. And then standard deviation also given that here, right? Now, the question that changed a little bit is if 500 people are randomly selected. Okay, that's something a little bit different, right? Previously, we say we randomly select 1 person, 1 family, right? 1 female, and find out the probability of that female spending less than $160, like that. Now, this question here is a little bit different, right? They randomly select 500 people, find out how many people they drink less than 1 cup of coffee per day. Is that clear? So that's the question, right? So remember, whenever we deal with this probability question, always draw 2 bell-shaped form, okay? Always draw that, okay? This one is what we call X, right? This one is what we call Z, standard. This X is not a standard because the center is 1.64 cups, right? So we have to convert to the corresponding standard curve. And then the transformation here is what? This less than 1. Everybody, when they ask less than 1 cup of coffee, so that means what? That means everything to the left of 1. Follow me? Is it right? So what we are trying to do here is we try to find out, like, if you randomly select 1 person, what's the probability of that person drink less than 1 cup of coffee? And then we multiply these 500 people. Will give us how many people out of those 500 will drink less than 1 cup of coffee. So it is still a probability question. Okay, so we are trying to find out this highlight area here. In other words, what's the probability of less than 1, right? So what do? We convert that to the z-score, right? So x minus mu is 1.64, is that right? That's the one we have here, divided by sigma. Sigma is given, okay? And then find out what's the corresponding z, right? Let's see here. Prog x equal to what? 1, right? So we got negative, everybody? Negative 2.68, tell me. Is this position should it be negative or positive? Should be negative, is that right? Because, I mean, you think about in the beginning, 1 is less than the average. So after the mapping, the new number should also be less than the average, 0. So it's expecting negative number, right? So in other words, if you got something positive, something is not right, right? So you got this number here, okay, so negative 2.67. Now we try to find out what's the probability to the left. Everybody, what do? Check the z-table. Follow me, right? So I'm going to do this one more time here, and I'm not going to do that anymore, okay? So we are looking for, oh, sorry. We are looking for negative 2.68, is right? Negative 2.68, where is that? Negative 2.68, let's see, negative 2.6, negative 2.6, right? This row here, 8. So that's the corresponding probability, 0.0037, right? So that's the number we are looking for here, everybody. So 0.0038. Oh, I think over there is like a 37, a little bit different, but it's like very, very, very small difference, right? So that's the probability, 0.38%. And then that's the probability of 1% drink less than 1 cup of coffee, right? And then we multiply 500 people. We multiply by 500 people, that'll give us like 1.9. So in that case, I mean, we don't really say 1.9 people drink less than 1 cup of coffee, is that right? Out of these 500, 1.9, that's like scary, is that right? So we run that.
Oh my God.
We run that like 2 people. So there will be 2 people out of these 500 people, they drink less than 1 cup of coffee. Are we good? So far, so good, everybody? So once you understand one example, the other example will be very straightforward, everybody. So that's the reason I encourage you try to understand the first example, right? Spend some time understanding what's going on, okay? Example number 4 here. Is going to be a little bit more tricky. Everybody, wake up. This one is going to be very important, and you will understand why it is important later, okay? I'm not thinking about taking a break here. I was thinking of continue so we can finish a little bit early today. Okay, wake up, everybody. Some test. From the result, we know that average of that test, right, is average about 200, standard deviation 20. Okay, so I mean, in terms of which kind of a test, we don't really care, but we know the average here 200. Okay, just information given. Okay, now the tricky part here, right? Need to select the top 10% of the students from that test. The question is, where is my cutoff? Where is my cutoff? For example, if I know this number here is right, if this is my cutoff number, then I know anybody beyond this number here will be in the top 10%. So in other words, the corresponding probability to the right is 10%, is right, everybody? So my question is, why do we not consider the 10% from the left? Like, why do I consider another 10% here? Why do I not worry about this case here? Like this number, right? Because of what? Because when they say top 10%, they are not asking the bottom 10%. Everybody follow me, right? This, if they are asking the bottom 10%, then that will be the new number, right? Everybody? On the homework, on the exam, right? I can easily change that to the other cases, right? The top 10%, the bottom 10%, the top 20%, the bottom 20%. Easy change those. Make sure you understand how would you do the calculation. Now, let's continue. We have the probability actually is given, is right, 10%. You see, we want to find out what's the corresponding cutoff X. That's like X we are looking for. Everybody, if you compare this question, this example with our previous example, this part here is more, let me see, what should I say, it's more tricky, is that right? If you compare our previous example, we always given like X. Like this number here, we started from 1, right? The other example here, we have 27, 31, and then 30.2, those are all different x, right? And then plug it into the formula, find out the corresponding z, right? So in other words, all the previous example, we are given x, we are given those 27, 31, right? We are given x, try to find out probability, right? We are given this one here, we are trying to find out the probability of drinking less than 1 cup of coffee, right? Example number 4 here is tricky because we are given probability first. You see, we are given the probability first and you try to find out the corresponding x. That's the challenging part. Okay, so it's a very important one. Now, what we are going to do here is actually the same transformation we mentioned earlier. Okay, so there's no change for that. You draw two bell-shaped form, right? Two bell-shaped curve here, right? Now, you don't know x, right? That's actually the one we are trying to find out. So in other words, when you plug into this number here, right? X minus mu 200 divided by 20. If you don't know x, how do you know z? You cannot know z either, is that right? So in other words, this number we cannot find out because this number x is unknown. We are trying to find out that, right? So in other words, we cannot do that way, okay? Now let's think about the backward approach here, right? So let's think about the 10%. That's the information we are given. So in other words, we are given the probability first, 10%. Think about that, right? So that tells us what? That tells us if I do the transformation, here should be also 10%. Follow me? Is that right? So here should be also 10%. In other words, the everything to the left should be equal to what, everybody? 90%. Follow me? Now, the z-table, remember the z-table, we can apply the z-table right now because we know the probability, right? So everybody, this is very, very important part. This is a common mistake happening here. So this point line here, this point line here is the probability we are given, is that right? I mean, we find out, do the calculation, 90%, 0.9. The questions now, when you apply this z-table, we are looking for 0.9, is that right, everybody? Let's see, where's point line? Point line, let's see, point line 0 here. Follow me, point line 0. That's the corresponding number we are looking for. Is that right, everybody? Point line 0. Follow me? Is that the case, everybody? This is a very tricky case, everybody. Point line 0, we cannot use this number here. We cannot use this number here, point line 0. Why we cannot use this case? Think about this point line. Is that a z or is that a probability? Right? Let's ask ourselves this question here. Point line is what? Is a probability. When you apply this number here is what? Is z. Remember? Right? So, but this one is what? Point line is probability. We cannot apply, oh, here is point line. That's what? That's z. Everybody? So that's the one I was trying to set up for you earlier, right? That's not right. We cannot get this point line 0 using this way here. We cannot. So what do we need to do? We need to find out the point line from the middle, from those number in the middle, those ones, okay? Now, let's see.
Would it be 1.29?
Let's try to find out which number here is close to point line. Let's see. Point line, like you see, two number here. It's very, very close. Is that right? We don't have exactly match. That's okay. So we can use either one, right, everybody? We can use this number here, so that will be a corresponding to 1.28. Follow me? Or we are using the other number here as 1.2 line, either one is fine. Or you can even use, how about we take somewhere in the middle, is that right? So it's like 1.285. Everybody, you see, I was putting that here. Either one is fine because the calculation will be a very small difference. Okay, so you can either use 1.28, 1.2 line, 1.285, you will get similar, very close answer. Are we good, everybody? I want to point out this common mistake. When you find out the 0.9 here, you want to use like those ones here, try to find out where is the number close to 0.9. Like those number is close to 0.8, right? 0.92, but we are like 0.90, right? Those two numbers here, very, very close. No other two numbers more close than those two numbers. Follow me? Okay, so now we got this number Z is equal to what? 1.28 or 1.285. Okay, so you see, that's the tricky part we find out. Now, what's next? We find out Z, let's go back to our table here, right? So now this Z is by the formula, right, is equal to X minus mu divided by sigma. Now we plug all the numbers, minus 200 average, right? So that's this number here, right? Now, this tells us is equal to what, everybody? It's equal to 1 point, follow me? We got this number here, right? It's equal to what? 1.28. Or you can say, you can say this is 1.285, right? So everybody, now you see that is, let me erase something, don't get confused, okay? So what I was trying to say is this way here, this one. Follow me? We don't know X. In fact, that's the number we are trying to find out. That's the cutoff we are trying to find out, right? We know beyond that score, right? Any number beyond that number, we are being top 10%, right? So we are trying to find out that X. Okay, so now in this equation here, can we solve for X, everybody? I'm counting on your high school algebra teacher, right? If you cannot do that, don't blame me, blame your high school teacher, okay? How do we solve that? Both sides multiplied by 20, right? Both sides multiplied by 20, cancel that, multiplied by 20, right? So then you have this side, follow me? X minus 200 is equal to this part, right? Now what's next? That's probably middle school, elementary school math, is right? So both sides plus 200, right? Both sides plus 200, then you got 226. That's the cutoff we are getting. So we can answer that the cutoff point, the 10%, top 10% cutoff points is 226. What does that mean? That means anybody beyond 226, they are in the top 10%. Everybody, follow me? So this kind of a question, right, on the homework, on the exam, right, I can easily change those numbers. For example, if you have some time available, try to see how can you solve this instead of top 20%. What if I change that to top 20%? Can you help me find out what's the corresponding cutoff? Okay, as an exercise, extra exercise, you can work on this after the class tomorrow, right? Try to work on that. Or you can try to work on this bottom 20%, right? Bottom. That case, right? So if you can solve for those situations, that means you understand this problem very well. Now, no matter how do I change on the coming exams, you will be fine. Okay, I think I told you too much. Okay. Now, the last example here, given blood pressure here. So I think this one is talking about like this. Usually when you talk about blood pressure, you have like one is like relatively high, one is relatively low, right? It's like high, low, two numbers, right? So this case here, when we measure people's blood pressure, we know the average 120, Okay, so that means if we connect the data of all the people's blood pressure, right, they should follow a normal distribution. Okay, and then the standard deviation also given here, right? So average is given, standard deviation is also given, and then we want to find out what is the lower limit and the upper limit for the middle 60%. Everybody? So I only draw one graph here, right? Ideally, I should draw another one here, right? I should draw another one here. That's our X. That's our X. This is the Z, okay? Because you see that like Z1, Z2, okay? For this X, where's our center? 120, follow me, right? That's the average. So this question here is trying to asking us, find out the lower and upper limit for the middle 60%. Middle 60%, if we break that into half, that means 30% here, 30% on each side, is right? So in other words, it's like somewhere, say here, we cut off here, that is 30%. And we cut off similarly here, 30%. Follow me? Am I going too fast? I hope I'm not going too fast, okay? Because
No.
I mean, the first few examples, we are going a little bit slow. I'm trying to speed up a little bit for the those other examples, very similar, right? So 30%, 30%, add them together, 60%. And those are the 60% in the middle, is that right? And then tell me what's the percentage here though, everybody? What that should be? Should it be 20%? Question is, why this one should be 20%? Let me ask you this. Here is the center, is that right? Here's the center. And then everything to the left, because all the probability on this curve is equal to 100%. It's like 1, is that right? You break this into half. So that means the one part is what? Is 0.5, is that right? Now we know this area here is what? 0.3. So then tell me this one should be equal to what? 0.2. Follow me? This one is 0.2. That's the reason I write down 20% here, everybody. Similarly, here should be also 20%. Follow me? So based on those information, can we find out what X1 here, X2 here? That's our question, right? So that X1 will be our lower limit. X2 will be our upper limit. So that we can say, between some number here to some number over there, that will be in the middle 60%. Those people should be healthy people.
Creating music is that we can kind of just put our experiences in the music, and that's how we share our and it's fun because that's our
Somebody trying to ask some questions, or I'm going to mute all the people. Is somebody trying to ask some questions? Yeah. No? Okay, I'm going to mute. I think it's background. Somebody. All right. So how do we find out, right? X1, X2. So what do we do here? We do the similar we mentioned previously, right? This one X should be mapped into like Z1, right? X2 should be mapped into Z2, right? And then now, we don't know X1, X2. We are trying to find out X1, X2, right? We are given probability. We are given those probability. Try to find out the corresponding X, right? Is the backward one. Remember, is the more difficult one, right? So that case, we have to, starting from the probability, when we are given this one is 20%, or this 20% here, right? Can we find out Z, everybody? How do we find out? This is a Z curve. If we know here is 20%, can we find out what's the corresponding Z1? Everybody, remember this curve here, is that right? So can we find out the corresponding Z1, right? Based on 20%, everybody, 20% is equal to what? 0.2, is that right? So let's try to see 0.2, everybody, 0.2, you see that one here, 0.20, 0.2. Is the 0.5793. Is that one? Let me see, 0.2, right? So 0.2, 0.5793. 5793. Is that right, everybody? That's not right. That's not right. I'm trying to set you up again. No, okay. I'm sick of that, right? I don't want to do that. Okay. I hope you understand why this is not right. Why we cannot use that number here, because if you think about this 0.2 is equal to what? Is a what? It's a probability. Is that right? Sorry, let me. It's 20% is a probability. So when you are using this table here, where is the probability? The probability is in the middle. It's in the middle, right? So in other words, when we are looking for the probability, we should looking for 0.2 from somewhere in the middle. 0.2, right? Let's see. 0.2, here's 0.9, right? That's pretty big. Yeah.
So
Well,
on the graph, is our goal to find Z or is our goal to find probability right now?
what do you think?
I want to say is to find Z because we're still trying to identify Z.
That's right. We are trying to find out Z first. Then we are going backwards, try to find out X.
Okay.
Is that clear? Same as what we did earlier. We are trying to find out like this Z here, is right? We got 1.28. That Z first. And then we try and go backwards, find out what's the corresponding X. Follow me? So we, back to your question here, we are trying to find out, based on this 20%, find out the Z. Is that clear?
Yes.
Question? Okay. Now, this table we mentioned, we cannot use the 0.2. 0.2, we don't see any 0.2 in this page here, right? Because this page here is all big number, like 0.9 something, right? So it's not this page, it's actually in the next page, okay? Oh, sorry, previous page, 0.2. Let's see, where is 0.2? Let's find out. 0.2, where's 0.2? 0.2. Use different color to do that. 0.2, you see we have like one number here. Follow me, this number here. This one, 0.2 something. Is that right? Is that right, everybody? It's like, sorry, this is, that's not the one. We have to be careful here. This is 2%, but we are looking for 20%. That's not the one. This is like 0.02, right? We are looking for 0.2. Okay, so this one will be somewhere 0.2, somewhere it's like here and here, is that right? Everybody? Between this number and that number. Follow me? So like 2005, and the next number is 01977, right? This number is bigger. This number is smaller, no good. There are only two possible choices, this one or that one, close to 0.2. So in that case, what do we say? The corresponding Z. Z should be, if we are using this number, should be equal to what? This number here should be negative 0.84. Follow me, everybody? Negative 0.84. Or if I use this number here, should be negative 0.85. Either one is fine.
We don't add both and divide by 2?
Yeah, you can also use like a negative 0.845. Yeah, 0.845. That's actually the one I'm using here. You see that? Negative 0.845. Follow me? Okay, so now once we find out this Z here, then we do what? Going backward. I'm trying to find out what's the corresponding X. And how do I find out this X? Remember, we have this Z transformation formula, right? Z is equal to, remember the Z transformation formula is what? Z is equal to X minus mu divided by sigma. Now we find out Z from a table already, that's our Z, right? How do we solve for X1, everybody? Counting on your algebra teacher, right? Multiply by 8 on both sides, right? And then plus 120, so you got 113. That is the lower limit, everybody? Lower limit. Follow me? That's our lower limit calculation, right? So what do we do here? One more time. we starting from the probability, right? 20%. That's very important. And then find out Z. Based on that Z, do the reverse calculation, find out what's X, right? Similarly, we can find out, oh, what's that Z2 should be? Because Z2 we are corresponding to what's the probability to the left? It's like 80%, is that right? So we are looking for this 0.8, everybody. Let me do this one more time, 0.8. We are looking for probability 0.8. Do we have that somewhere? 0.8, let's see. We are looking for 0.8. Is this the one, everybody? 0.80? This is the last time I'm trying to trick you, right? That's not the number we should use, everybody. 0.8 here is what? Is a probability to the left. This 0.8 here is what? Is Z. That's not right, okay? So we are looking for 0.8, should be some number, let's see, that's some number here actually. Follow me? That is close to 0.8, is that right? So the number should be like either 0.84 or 0.85, or you can say somewhere in the middle, 0.845. That's totally fine, right? So 0.845, that's the 0.845. You see that one I have here, 0.845, see? And then based on that, to do the calculation, find out the upper limit is 127, x2. The one thing, if you pay some attention here, you may realize, like these two numbers here, what's the relationship, right? Everybody? Like somehow you got a negative and I got a positive. Y is like almost the same. One is plus, one is minus. Because of what? Because it's the symmetric case. Symmetric